And welcome back to the channel, everyone. Today we're going to touch on equations, and we're going to review some equations with variables on both sides. So just as a review, when we were working with variables on both sides of the equation here, we wanted to move our smaller variable first. Okay? And that's pretty much my general rule of thumb. We want to find that smaller variable, move it first, either from left to right or right to left. Okay? So my smaller variable here is that negative 3x. So as I review, I'm going to add 3x to both sides. We're going to get 0x over here, make it negative 12 is equal to 10x plus 15. And now I just moved all my variables to the right side, which means I need to move the numbers left. In this case, I'm going to subtract 15 from both sides to get the variable alone, to get my 10x alone. I get 0, negative 27 is equal to 10x, and divide both sides by 10. So then x is equal to either negative 27 tenths. If you want to make it negative 2.7, that would work, or negative 2 and 7 tenths. So that should be a review and moving that variable on both sides. So sometimes we get these solutions where this is where we see there is only one solution, one unique solution to this equation. And that equation would be negative 27 tenths. However, we're going to learn today that there are sometimes some special solutions where it's not just one solution. So here I have a little bit of a denser problem, and I'm going to compute this a little bit. So my first step in all of these is to look to distribute, look to combine like terms, and then move my variables, okay? And again, we're gonna move those variables first prior to anything else, okay? So once we get through distributive property, combine like terms, then we wanna move our variables. So we wanna get it into a situation where it's just a variable and a number is equal to a variable and a number, and then we can operate, okay? So I have a bunch of stuff going on over here. I have some distributive property. So I'm going to make that 2w plus 4 plus 3w. On the other side, I distribute the 5. So I have 5w plus 5 plus 2. So now what I'm going to look to do, I distributed, that part's done. Now I'm going to combine my like terms. 2w and 3w. On the same side, that becomes 5w plus 4 equals, on the other side, I combine the 5 and the 2 equals 5w plus 7. And now I've combined like terms, so I have variable number, variable number. Now I'm going to move my variables. Well, we said we want to move our smaller variable first. Well, I have 5w and 5w, so they're equal. Well, in that case, I'm going to subtract 5w from both sides. And so it really doesn't matter which one you use. And I end up getting 4 on one side, and that's equal to 7. So here's a unique solution where students typically look at this and say, well, I think I did something wrong there. Actually, you didn't. You actually solved this correctly. This is a unique solution because we know actually we have a false statement here. 4 does not equal 7. And what that means is within this equation, I actually have no solutions that will make it a true statement. And you could go back up here to where we have the 5w plus 4 equals 5w plus 7. I challenged you to find a number times 5 that when you multiply it by 5 and add 4, you will get the same number when you multiply it by 5 and add 7. It's just physically impossible in this case. So we have that special solution where there is, in fact, 0 solutions. Or in this case, we use the null set for no solutions. Okay? So right now we've gone over, we have one solution, we have no solutions. Now we're going to get to our third type of special solution. Here, again, I look to, do I have a distributed property? No. I look to combine my like terms. Y plus 2y is 3y plus 7, and that's equal to 3y plus 7. Now I'm going to move my variables. The smaller variable, well, they're the same size, so I'm going to subtract the 3y from both sides. And I end up getting 7 equals 7. So last time we had a false statement. This time we have a true statement. So our false statement, when we were false, we had no solutions, the null set. When we are true, we have the exact opposite. We have this symbol that says all real numbers. And what that actually means is if a null set is no solutions, all real numbers means we actually have infinite solutions. So it's the exact opposite. Okay? So all I would have to write down here would be my all real numbers, and that's correct. And again, look at how we would substitute in here. 3 times any number, use like -4, and I add 7 would be equal to 3 times that same number plus 7. It wouldn't matter if I changed that to 3 times 2 plus 7, because in fact, it's the same equation on both sides. So that's why we actually get infinite solutions. So those are the 3 different types of special solutions you have. Either 1, where you just get x is equal to some number, 0 solutions, which we get that null set, or infinite solutions, where we get all real numbers.